All right, so welcome back. Transforming parabolas to quadratic relation. Now in this video what I'm going to do is, because I guess you've been studying these quadratics, and this one, as you see, is kind of in the vertex form where the a kind of stretches or compresses the parabola, and then the h and the k just simply tell you what the vertex is. Now I'll put a link up above to this particular format so you can refresh if you've forgotten it. What I'm going to do is, instead of now dealing with these quadratics where the equations or the relation is given, what if you were just given an actual parabola or some kind of a graph, and then you had to extract from that graph and create an equation out of it or a relation out of it? That's what I want to be able to show you. It's actually not that bad when, of course, you're dealing with kind of parabolas that are either on grid paper, and you can tell more or less kind of what the values on the parabolas are. If it's a random parabola, you can probably approximate it using exactly the method that I'm going to show you, but you probably won't be able to come super extremely perfect. But in reality, in real life, when you are finally applying these things, eventually when you finish up your school and then maybe you're going to be dealing with this, well, nothing is perfect. So the tools that you're learning are simply just to give you a sense of like, okay, what tool can I take and then apply it? And it's a great tool to have, to be able to take, let's say, a graph and then create an equation out of it, or an approximate equation out of it. So let's take a look and see. So again, what we're going to try to do is we're going to try to take some parabola. Now, it doesn't matter what parabola it is. All right, so let's say if I draw one like here, all right, let's say this was our parabola. Now, our parabola is always consisting of a vertex. So we have a vertex right there. So our vertex right here, that is one thing that we know of. So if somebody just gave us this graph, then we're like, well, okay, well, this is the vertex. Now, the vertex always happens at the value of h for x and then k for y. Now, I'm picking this h and k completely arbitrarily. It doesn't really matter what you call it. So it just depends on how you're studying it in school, so don't get thrown away if somebody uses some other parameter for h and for k. Now, so this particular vertex, so what we have is, okay, so we know that that vertex is right there. Now, if we can extract that vertex, right, as close as we possibly can, then we're very much almost at the actual quadratic relation. So we have this h and this k, and then the only thing really that's missing is this a. Now this parabola is looking upwards, so we know that a already is going to be positive. Now, how much does it compress, right? So how much does it compress, or how much does it stretch this parabola? The only way to find out is really you got to be able to take, and typically you can try to take maybe a point, so first, and then take maybe another point or two, and then repeat the process of solving for this a. So I'm going to show you what to do. So for instance, once we have our vertex, which is the easiest one to locate, then you simply are going to come along and you're going to, let's say, pick some value, right? So on this particular plot. Now, for this value, it's going to give you a value for y and then a value for x. So whatever this might be. Now, I don't know what this is because I drew it arbitrarily. But let's say, this is kind of going back in, and this would have been your value for y. And then, so here, right here, if I go all the way down, right, so whatever this might be your value for x. With these two values that you have, now you have a point. And when you substitute that point for y right here, so you would have that substituted, and then you can substitute this in here for x, you already have your h and your k. So now the only thing that's missing is just your a. So this will be the only thing missing. And if that's the only thing missing, you can solve. So you can substitute the point, you have your vertex, and then you can solve for your a, and then you have your quadratic relation, and then you can write it down, or at least approximate it in some way, depending how good that parabola that they gave you actually is. So let's try that, all right? So we're going to try this particular process kind of step by step. Now I have preloaded these. Now I'm using decimals within here. I've used decimals in many of the videos. So, you know, thank you to Decimals. No, they're not sponsored or anything by Decimals, but it's an amazing tool. Maybe one day I'll be sponsored, but for the moment, it's just a matter of just trying to help students out. Okay, so here is a parabola, right? There is nothing on it except, you know, we have a grid, and then what we're going to do is we're going to try to create our equation. So our equation, so let me go back in here, and so our equation is going to be of this form. So it is y is equal to a. That's going to be the easiest equation for us to be able to write down. That's our equation. So again, so step number one, just find out your vertex. Now this vertex right here is pretty simple. That vertex happens on the grid basically at the point 0, 0. Well, so that's pretty easy to be able to fill out. So what you have is, now once you have this vertex, you know, you can pick that off, and I can see that it's 0, 0 there because that's the lowest point. Now the a is going to be positive because it's looking upwards. But now since I have this h and this k, so now really what this boils down to is a, now h is 0 and k is 0, so this is going to be just x squared. So I have my first step, so that's my vertex. If your vertex was shifted somewhere different, and I'll give you a couple of other examples, you'll see that, you know, you're going to have to fill that in. Now what you do is you're going to be taking a point. Now take a convenient point from the parabola that you can read. So for instance, I'm not going to take, let's say, you know, this point right here. Okay, so if I, you know, blow this up, I'm not going to take a point right here because it doesn't really fall on the grid, right? It's not a convenient point. I mean, although I guess it could be, I could approximate it in some way. You know, I'm not going to take, for instance, a point like this, again, because it doesn't exactly fall on the grid. But here, notice that the parabola, what it does do for me, as I kind of zoomed in, it does nicely fall on this grid right there. So I can read off the value for y, and then I can read off the value for x. Now, reading this off, so notice clearly this is the point 1, 1. All right? Now, that's the actual point that I have. And, you know, you could have picked any other point. I mean, we could have picked this point, which would have given us negative 1, 1. And we could have picked some other points. You know, if a nice graph like this is given, you can check a few points for yourself. So, for instance, you know, I have a point right here, and this actually falls right in there, where it's 2. Okay, so that point would have been 2 and 4, because I'm reading it off right from the graph right there. So this goes all the way there and then all the way down. Now, which points you pick, it doesn't matter. But once you have the point, and it's a convenient point to work with, so in those cases, so what we have is now we basically substitute it in for x and then for y. So I'm going to pick the easiest one, which is 1, 1. So that's the one that I have right there. And that's the actual point that I'm going to carry. Okay, so this is a point now, so that's going to be 1. Okay, now a, okay, so what I have, because I don't know what a is yet, but I'm going to substitute 1 for that, so that's going to be this. And then, of course, you know, this is pretty easy to tell that a is going to be 1. So this parabola, okay, so the way that we have it written is basically just x squared. And I have found this out from, okay, taking a look at this actual chart that I'm carrying out, right? So at the actual graph. So again, step 1, find the vertex, and then step 2, find the point. Now you want to find typically a point which is different than the vertex, because if you find the point that's going to be the vertex, it might zero out your a. So just find always a different point. Let's try this on another example. So here is another graph right there. Okay, so that's another graph that we have. And this one actually doesn't fall. So let me kind of zoom out in here. It doesn't fall at 0, 0, right? The vertex is different. So again, so what I'm going to do is I'm going to find the vertex first. Well, the vertex here is right there. And that is, okay, so notice these are the values. So that's my vertex. And then the line of symmetry would have gotten through that x. So right away I know y is equal to a. Then I have x. Now my vertex right there is 2, 1. So this is going to be minus 2. You have to remember that from the formula. And then the y value is always plus 1. So now you have almost figured out the entire thing. Again, my parabola is looking upwards, so I know that this is going to be positive, but I still want to know what value that is. And now I kind of scan and see, all right, what's the best point that I could pick? So I'm kind of looking through and I see, okay, let me pick this point right there because it goes through. All right, so this is what I'm going to have. Now that point is on this parabola and it is 1, 4. So that is the point that I'm going to carry out, and I'm going to substitute it into my equation, and then I'm going to solve for a. So here, if I do that, that's going to give me my y was equal to 4 is equal to a. Now a I don't know yet. My x was equal to 1. That's the point, minus the 2 squared plus the 1. And now again, all I do is just solve for a. So this is much simpler to do. So 4 is equal to, now this is my a. 1 minus 2 is negative 1. Negative 1 squared is just 1. And so that is going to be just a on its own, plus 1. And now you just shift this over on the other side, and you notice that this is 4 minus 1 is equal to a. So a is equal to 3. And there you have it. So you have your equation or relation. So that's going to be 3. And then you're going to have your x minus the 2 squared plus your 1, and there is your relation. And then if your teachers or something, they ask you to put this in standard form, then you can just expand the actual x minus 2 square and expand it out, collect your like terms, and then you will have it in your standard form for your quadratic. And that standard form, would have been simply, ax squared plus bx plus c if necessary. This is in the vertex form that you have right there, which is a lot more convenient in terms of graphing. So that's another example that you have. Let's look at a final example, but I hope that by now you kind of see what the process would be. So now this parabola is looking downward. So we know that A is going to be in the negative direction. So it's going to be negative. And I'm going to pick off now. So again, the vertex is, okay, so it's nice because, these are on grids. So this is much nicer to pick off. So here's my vertex, which is negative 4, negative 2. That's what I have there. That's my vertex. And now I'm going to pick a point. It doesn't matter what point, but I'm just scanning through. And, let's say it goes through right here. So I'm going to pick off, this is going to be my second point that I have to find my A. And that's going to be negative 6 and negative 4. So that's what I have for that. So let's see it, okay, and let's find out what this might be. So here, first I'm going to start off. So negative 4, negative 2, y is equal to a, and then it's going to be x, and it was negative 4, so this is going to be plus 4 squared, and then minus 2, which is your y value, so that's your vertex. Now the second part is, I'm going to substitute the second point. So this is going to be negative 6 is equal to a, and so that was negative 4, negative 6. So pardon me. So negative 4 for y, and this is going to be negative 6 plus 4 squared minus 2. And let's solve it. So this is going to be negative 4 is equal to, now this negative 6 plus 4 is negative 2. Negative 2 squared is 4. So 4 times a, which is going to be 4a, minus that. Bring that negative 2 over on the other side. So I'm going to bring it over. So it's going to be negative 4 plus the 2. It's going to be equal to 4a. So this is negative 2 is equal to 4a. And now divide by 4. And then you have your a. So your a, it looks like it's basically, 2 over 4 is just a half. Or I guess you can put it 0.5 if you want it as a decimal. So your overall equation, so I'll leave it as a fraction there, so negative 1 over 2, and then x plus 4 squared minus 2. And that's how you would actually utilize these parabolas and then transform them so you have equations out of them. It's actually not that difficult. Now, sometimes what I would encourage you to do is, I mean, these graphs were actually, you know, on grid paper. Sometimes what you want is, if you can't really tell, you know, maybe pick a couple of points or 3 points and then solve for your A few times to see that you're getting the same value, right? So because in case you have to approximate it in some way. But this is how you would do it, typically when you are given it on a graph piece of paper, and then you kind of know that it is a parabola. All right. Okay, so thanks for watching, and we will see you in a future video. Okay, so bye everybody. Take care.